In this video, again, we'll do an example for each set, but actually I'm going to do two examples with you for 10 through 12, and then I'll do one example for the last set. Example 3 is one of the two examples for 10 through 12, and our directions here tell us to solve by factoring and to verify the result by using the calculator to graph the expression resulting from moving all the terms to one side. And then copy the graph and find the zeros using your calculator to verify that your answers are correct. So we'll talk about the graph in a minute, but I have a picture there of what happened when I graphed my solutions. But let's start by solving this analytically. And anytime you recognize that you're solving a quadratic equation, you should begin by moving all the terms to one side. Unless it's obvious to you before you move the terms that you're not going to be able to factor what you have, and then you might choose to complete the square, but you'll still want all the terms on one side if you're going to use the quadratic formula. In this case, we're going to solve by factoring, and everything should be factorable. So we set up our binomials, and the third term is subtracted, which tells us we're going to have one of each sign, and we need the factor pair that multiplies to 20 with a difference of -1. So obviously that would be 5 and 4, so we put the 5 with the minus and the 4 with the plus. And if it's not a nice friendly little number like 20 and you need to, obviously you can go back and list your factor pairs and think it through on paper, but one this simple, I don't expect you to do that every time. And our solutions are 5 and -4. And so we've solved by factoring, and now we did the verification by picking up our calculator and graphing. And when you do, again on the Inspire, it will display your equation. And remember, you're going to do this as one parabola by moving all the terms to one side, and then use the steps outlined in your packet, your study guide, to help you find these zeros. And this is what you should see on the Inspires, but if you have any other kind of calculator, basically, at the bottom you should see displayed x equals -4, y equals 0, and then you would repeat the process and get a similar set of results where you'd have x equals 5, y equals 0 displayed at the bottom of the screen. And again, I will be more than happy and available to assist you with doing that on your calculator. But that's all you have to do for that one. And then you're going to graph it on after you've seen it on your calculator, you'll put it on your graph on your paper. And this one's centered nicely around the y-axis. So and since you're just looking at the zeros, we don't really care where the bottom of the parabola came out because it's outside our viewing window anyway. And so we're going to plot 5, 0, and then we're going to plot -4, 0. Now if you'd prefer to zoom out to where you could see the parabola and get some more practice with the graphing strategies we discussed last week, then that's fine too, but for my purposes this is all I'm looking for. So then you want to just sketch, and you don't want it to be a straight line, so you shouldn't be using a straight edge here, and you can kind of just approximate what's going to happen so that it looks like this is a parabola somebody zoomed in on. And then this is 5, 0, this is -4, 0, and we need our arrows, and the y label on the y-axis and the x label on the x-axis, and that problem is complete. So the second set, in a lot of ways, is going to go a lot faster and in some ways be easier. How easy it is depends on how strong your factoring skills have become. Again, this is quadratic. I know it's quadratic because I see an x squared, and I can't use just simple like reverse order of operations because the term on the other side has an x. So that tells me to get all my terms on one side, which I do by subtracting 39x, or you can just remember that and I always taught my Algebra 1 students, if you pick up a term from one side and move it to the other, just change its sign. And when we do that, we get 13x squared minus 39x equals 0. And then remember, and your red flag sort of will be that you have something like this that just has two terms, but you want to start always by looking for anything that you can take out of all the terms involved. And in this case, we can take out 13x, which leaves us x minus 3 equals 0. So we know that the product of these two is 0, then that means 13x is 0 if x is 0, and x minus 3 is 0 if x equals 3. And then when we look at the solution from my graph, we see that we have a 0 at 0 and a 0 at 3. And it should not surprise us that this is a very narrow parabola because we had an a of 13, and remember that was one of the aspects of the graphs that changed because of a. So again, we set up our axes. Everything kind of symmetrical and centered is fine because you're focused on the zeros here. X and Y, and we have a 0 at the intersection, and then we have a 0 at 3. And this one's so tall and skinny that it's gonna kind of very slightly angle. That's a bad one. Let me try again. A very slight angle, but not a straight line. I'll keep trying to get it. This is kind of hard to draw on this thing, but make it look like it's going to meet. That's not a very good example because this clearly is not meeting at the bottom. So your lines are almost going to look straight on this one because it is. It's terrible. I keep trying, it'll do better. That's a little better, but it's a lot easier to do on paper. So do your best. And that takes care of this one. Now example 5, our last example for the set. And this one is for 13 through 15, the last part of your handout. And on this set, again, we're going to solve, but we're going to solve by completing the square. And this is probably the last time I'll ever require you to do this. But I'm just trying to make sure that you haven't lost that skill and kind of set it aside because we've taken a test on it now. So we're going to solve by completing the square. And remember to do that, when we copy the equation down, we want to leave a space on the side where we're going to be completing the square. And remember to complete the square, and let me switch colors here, we're going to add the constant term we need that would make this side a square. And it's always half the middle coefficient, which would be 5 squared. And it's always added, never subtracted. So we just added 5 squared to the left, so we're going to add 5 squared to the right. But just for simplicity's sake on that side, we're going to go ahead and make it 25. And then on the left, we rewrite that side as x minus 5, the quantity squared, equals, and 11 plus 25 is 36. And then we solve. Once we get it, the square completed, now we can take the square root of both sides, and we get x minus 5 equals plus or minus, and I should have put my plus or minus on the previous step, plus or minus 6. So x equals 5 plus or minus 6, because when we add 5 to both sides, the 5 becomes positive. You wouldn't leave your answer this way because it's easily simplified to an actual pair of answers, which would be 5 plus 6 gives us 11, 5 minus 6 gives us negative 1, and those are our two solutions, which matches our pictures here. And again, I'm showing you both views because this will happen frequently throughout this course. You're going to go to your calculator to verify your solution or to get the graph for whatever reason. And when you graph it, you're going to see what we see up here at the top, which is not the ideal view for what we're trying to do, because we want to get a view of this graph that shows us both solutions. Well, this is where knowing something about parabolas is going to help you, because we know that because our A is positive, this should be pointing up, and we can see the way this side slants that this is the left side of the parabola we're seeing. We also know that based on what we just solved, that we have a 0 at 11 and negative 1. Well, obviously this is the one at negative 1, but we want to ignore that for the moment because we want to be able to see them both in the same window. So this is our second graph, and we're going to move it up here and let's forget about the first one by moving it. And this is the view you'll want before you find these zeros. Again, on the inspires, and you'll still have to do a two-step process to locate both of these zeros, but they will display together. On the other calculators, they'll display 1 0 at a time. So, and again, I will assist you with that as needed over the 2 days we'll be working on this in class. So now we want to sketch that on our paper, and we verified that our answer is correct. Now, of course, if you graph it and you get the wrong solution, there's one of two possibilities. Either the solution you got was wrong when you did it by hand, or there was some typo in your graphing. So that's why we're spending 2 days on this, just to see all the ways what seems like a really simple process can go wrong, because you want to get really adept at that for the purpose of working independently and having all these strategies at your disposal over the course of the semester. So, you know what, let me try that again. I'm going to move the y-axis over here to the left. That would be smart, because one of our zeros was way over here at -1, and one of them is way over there at 11. So we'll put our arrows on our graphs, label our axes, and you don't have to do anything about a scale as long as your scale is 1. So, especially since you're going to be recording the coordinates as you go. So that's -1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would be right here. So those are my 2 zeros, and I'll wait to label them after I draw this picture. And again, I want to make it look roughly like the one that's there. And when I look at my calculator screen up there, what I see is something like, let's try this again. It goes way down like that, and then on the far side it should mirror that slant. So I'm going to go, and again, this is not a great medium for drawing a parabola, but that's about what I should see on your paper. And then the coordinates of this point, of course, would be 11, 0, and the coordinates of this point over here would be -1, 0, and that's all you have to do for those. And that's the end of this set of videos.